Honda has been a powerhouse of powertrains for decades. Not only have they raced under their own name in everything from F1 to MotoGP, but they have also supplied engines to other teams, such as Red Bull. And Red Bull has used those engines to help it win multiple world championships in the 2020s. The second generation NSX was developed as part of that heritage. For Honda, the NC1 NSX was all about the new sports experience. The transmission is a huge part of that experience. Other supercars of the time had 6- and 7-speed transmissions, but Honda crafted the first longitudinal 9-speed dual-clutch transmission in the world. But Honda didn't create it just to be the first. They built it to balance supercar performance with the daily driving experience. David and I agree that this is the best transmission we've ever had the chance to use, so we think Honda nailed it. According to a Honda R&D article, the transmission development team had 4 main goals. The first goal was to optimize gear ratios while simultaneously shortening the length of the transmission. To achieve this, they eliminated the first gear shift mechanism and then shared transmission gear trains among the other gears. Additionally, they opted for a parallel multi-shaft structure and placed odd stages on the main shaft with even stages on the secondary shaft. All told, these decisions reduced the length by 120 millimeters from the traditional non-compact design. And compared to a competitor's 7-speed DCT, the NSX's 9-speed was 35 millimeters shorter. In the end, these changes limited the overhang and reduced yaw moment during turning, which further allowed for more design options and improved driving performance. The second goal was to increase the transmission's ability to transfer high power from the engine and direct drive motor. The parallel shaft design that decreased the length also helped the dual wet clutch transmit torque from the engine and the motor to the various shafts. But that wasn't enough to create the experience that Honda wanted. The team decided to use the dual wet clutch from the 2015 Acura RLX as a base. That meant the dual wet clutch started with a torque capacity of 370 Newton meters, but by the time the NSX design team was done with it, it achieved a capacity of 550 Newton meters, while remaining the same size. To achieve this, the team optimized the thickness of the steel plates and increased the number of friction discs. They also polished and used precision surface finishing to improve the durability of the hypoid gears, plus used a high silicon aluminum material with abrasion resistance for the transmission case. These design implementations increased fatigue strength of the case by 20% compared to the 2015 RLX base. Finally, the NSX team opted for 2 types of oil to help with power and cooling. They separated the oils in the clutch room and gear room. They also developed a new oil for the gear side, which provided high viscosity and high oil film retention under high temperature and high pressure, which supported the goal of high power output. These oils also aided in the third goal, to achieve thermal feasibility during high load driving. The oils themselves were great, but if the oils became too agitated and aerated, they would lose their cooling efficiency. To minimize this risk, the team added a baffle to the clutch room to limit the rise of the fluid. They also added a forced lubrication structure to the gear room to ensure a consistent supply of lubricant. However, fluids alone can't keep the transmission cool. For the NSX, the team installed 4 heat exchangers. The dual wet clutch has a heat exchanger by water, a heat exchanger by air, and a heat exchange between the ATF and gear oil. The gear side has a heat exchanger by air that is located at the left front of the vehicle. The team's final goal was to balance acceleration performance and quietness. To achieve this goal, the team built first gear with a low ratio, which provides instant launch. On the other end, they used a high ratio to achieve quieter cruising at higher speeds. They also shortened the shifting time by using a high-capacity double cone synchronizer, a high-rigidity shift fork, and a gear actuator. The double cone synchronizer increased the capacity from 2nd gear to 5th gear to absorb the large amounts of energy. The increased surface area allows the synchronizer to use more friction surface area, which raises the RPM range and provides for faster shifts. They also changed the material in the blocking rings from cold-rolled steel to a chromium molybdenum steel for better durability. The shift fork, however, was made with high-strength cast steel, and its shape was optimized to improve the balance of the load on the tips of the fork. By achieving each of these goals, the NSX transmission team created a super responsive DCT. To quote David, "This is the best DCT transmission to date." Thank you for watching.